I am doing a recap on the topic on probability very briefly, and in probability I'm only going to focus on the types of events that occur in probability. So types of events, there are of three types. We have what we call the mutually exclusive events, right? We have then the ones that are not mutually exclusive, which can be divided into two. We have the independent events, and we also have the dependent events. So these two are not mutually exclusive. This one is mutually exclusive events. So what do we say about mutually exclusive? These are events that have no common sample point. No common sample point. The occurrence of one excludes the occurrence of the other one. Occurrence of one event excludes, this is very important, excludes, and I'm writing in capital letters, excludes occurrence of any other or of other events. So what that one tells you is, from your set theory knowledge, that the probability of A union B, if A and B are mutually exclusive, should be given by the sum of the individual probabilities, because they have no common sample point. If you are to draw a Venn diagram here, then you are saying these two events A and B are disjoint. They have nothing in common. So the union will be given by the sum. So this is now the condition that helps you check whether any two events are mutually exclusive. And in this case, because they have no common sample point, the intersection of the two events is actually equals to 0, because it gives you an empty set. So that's about mutually exclusive. But on the other hand, we have the independent event. Independent means they are independent, but unlike the mutually exclusive, they have some common sample point. If you are to draw your Venn diagram, then it means the two events are sharing some values. If this is A and B, they are sharing some values here, so the intersection exists. It is not an empty set, and therefore there will be a probability for A intersection B. But what makes this event independent is because the probability of occurrence, okay, of one event does not affect the probability, I'm using the term probability, of occurrence of the other event. They do not affect one another as far as their probability of occurrences are concerned. So in that case then, the condition that would help you check whether any two given events are independent is by looking at whether the probability of the intersection is equivalent to the product of the individual events. So this is what helps you note whether any two given events are independent. Then when we come to the dependent now, it means here, because in the independent, the probability of occurrence of one event, okay, does not affect the probability of occurrence of the other event. But for dependent events now, it is the opposite. The probability of occurrence, okay, of one event affects the probability of occurrence of the other event. The probabilities affect one another. It's like where you are drawing some two fruits from the bag, an avocado and a banana, and you go in and get, this is the first fruit. The second fruit is A2 and B2. Now the probability here will be affected by what happened first. If there were 7 fruits in the bag that were avocados out of a total of 10, 3 bananas out of 10, the probability of getting a second avocado depends on what happened first. So you can see they are depending on one another. This is what we call now dependent events. So for us to be able now, therefore, to understand about dependent events, you have to think of what we call conditional probability. That is the probability of an event A given that an event B has already occurred. This means A given B. And the probability of A given B would be given by the intersection. You can see at the end here, when I talk about an avocado followed by an avocado, I'm basically talking about A1 intersection A2. And here, the second probability, or the probability of getting a second avocado, given the first was an avocado, it implies it is a conditional probability of A2 given A1. And you see, when I multiply these two, like previously you have been doing when you're using a tree diagram, then the product of these two gives me an intersection. That means probability of A given B would be given by the intersection divided by the probability of the given event. Alternatively, if I wanted to look for the probability of B given A, then this would be equivalent to, again, the intersection, but you divide by the probability of the given event A. So this is now what you use to test whether two events are dependent or not. Finally, when you are dealing with these two, the dependent and the independent, what happens to the union? Let me go back to this Venn diagram. If I want to look for the union of A and B here, A, the number of elements in A union B, you can see very clearly, I'll pick the values of the numbers or the number of elements in A. I add to the number of elements in B, but I have picked the intersection twice. When I was picking A and I pick B, I've picked the intersection twice. So I subtract the intersection A intersection B. This is from your set theory, and you can transfer it directly to the intersection, to the probability concept. Probability of A union B is equals to the probability of event A plus probability of event B minus probability of the intersection. So this one applies to the dependent and the independent event. In other words, it applies to the not mutually exclusive events, because mutually exclusive, you add the individual probabilities. So those that are not mutually exclusive, which may be either independent or dependent, you add the two individual probabilities, but you subtract the probability of the intersection of the two events. And basically, this is just a summary of the types of events that we have as far as probability is concerned. Follow up the next video for a demonstration of application of this to some real life situations. Thank you.